Okay, today we're doing lesson 2.12. That's module 2, lesson 12. And this is the last lesson that's going to be covered in your weekly check-in tomorrow, okay? And your learning goal is very similar. It's kind of like combining all the skills we've been learning this week. What's the main thing we've been learning how to do this week? Gia?
Estimating to find, multiplying decimals.
Yeah, the main thing we've been doing this week is multiplying decimals by whole numbers, right? Have you noticed we did using area model, we used standard algorithm by changing the unit into unit form, and yesterday we talked about how we can use estimation. But the main thing we've been learning this week is how to multiply decimals and whole numbers. Okay, so that's basically what your entire weekly check-in will be about tomorrow. But remember, you need to be able to do it using an area model. Those of you who are wondering how to study, you might want to write this down. You want to be able to do it using an area model, how to do it by renaming the units. What do I mean by that? Renaming the units. Renaming the units. Martin?
Taking a phone number with a decimal.
Like 23.2?
Yeah.
And calling it?
And turning 230 to 100.
Yeah, so this is an example of renaming the decimal, okay? When you take a number with a decimal and taking out the decimal and renaming the units. Okay, so once again, area model, renaming the units. We also learned how to use estimation, right? And today we're going to talk a little bit more about changing the problem and then undoing the change. You guys might know what I'm talking about, right?
Yeah.
Very good. We're going to look a little bit more at that today. But all 4 of these strategies will really help you if you know how to do all 4 on the test tomorrow. Okay? Good. So the directions tell us to do a couple things. It says to estimate first, because we know that that's going to help us figure out the zone of our answer. And then it says solve using an area model and the standard algorithm. Okay? So we're going to talk about how we can do that. Okay? Let's first estimate. 2.45 is pretty close to what factor?
2.
Okay, yeah. And 305 is pretty close to what number? 300. So therefore, 2 times 300, our real answer, Haley, should be pretty close to what number? Good. So we can see that our real answer should be pretty close to 600. And we're going to keep this information off to the side just to help us out. Okay? We're done with estimating. Now it says to draw an area model. Okay, for an area model, I can think that 2.45, let's rename those units. If I get rid of that and I just want 245, what would the unit be? 245 what? Hundredths. Okay. Good. So then if I'm going to draw my area model, let me make this a little bit smaller so we have more room for our area model. Oops, hold on one sec. So one of my factors is now 245 hundredths, right? So how can I break up 245 hundredths to make it easier to make my area model? Jithia? 200 hundredths. I'm just going to write a small h to mean hundredths, okay? 40 hundredths, and of course, 5 hundredths, right? And on the other side, I have my other factor, which is 305. So I can split that up into 300. And I don't need to write any units because they're ones, aren't they?
Yeah.
Okay. Oh, do I have to write 0 tens?
No.
No, I could just write 305. Okay, very good. Okay, so this first box over here, I can do 300 times 200. So I can think 3 times 2 is 6. And then I have to add how many zeros?
4.
And most importantly, I need to write what? H, because they are? Hundredths. Good. Yeah, let's just write H. I'll write hun. Okay? Next box, this one right here, I can do 300 times 40 hundredths to find the area. So I can think 3 times 4 is? 12. And then how many zeros? How many?
3.
And most importantly, I need to write my units, which is? Hundredths. Okay, this one I have 300 times 5, so I can think 3 times 5 is 15. And 2 more zeros, and of course my unit is hundredths. It's super important to write hundredths, because if we don't write hundredths, what might happen? What might happen? Sanatin?
We might lose track of the unit we're working in, and then we'll write the answer in 1.
Exactly. Okay, to find this one, we have to do 5 times 200 hundredths. So 5 times 2 is 10. And then how many zeros do I need to add?
2.
How many?
2.
Marvin, let's make sure we're focused. And of course, the unit is hundredths. To find this area, we have to do 5 times 40. So 5 times 4 is 20. and then one more 0, and of course we're working with hundredths. And then over here, we have 5 times 5, which is 25 hundredths, okay? Now, in order to find the total product, we have to find the partial products, right? We're going to add these up first. So we have 60,000 hundredths. We have 12,000 hundredths. And then we have 1,500 hundredths. Do you guys agree? Okay. So all together, what do we have? 3500. We have 73,500 hundredths. Now, if I want to write that into standard form, what would it be? What would it be? If I want this rightmost place to be in the hundredths form, where would I need, or hundredths place, where would I need to put the decimal point? Marvin?
Oh, you need in between the 5 and the 0.
So therefore, 73,500 hundredths is the same as what number, you guys?
735.
Okay. Is that our final answer?
No.
It's just a partial product, right?
Yeah.
Now let's find this partial product here. Okay. What's my first number?
1,000.
1,000. What's my second number? 200. And what's my third number? 25. And these are all what units? Hundredths. Okay. So if I add this up, I have 1,225 hundredths. Where do I put the decimal to make it standard form? Kish?
You put the decimal point between the two twos.
Good. So it's 12.25. 12 and 25 hundredths. Now if I want to find the total product, I just have to add up my partial products, right?
Yeah.
Okay, so I have to add up 12.25 and 735. So go ahead and do that. What did you guys get? 747.25?
Yeah.
Very good. Now let's check. Our estimate was it should be close to 600. Is it pretty close to 600? Yeah. Okay, not too far away from it. Very good. So far we've estimated. We've also used an area model. Now we have to use a standard algorithm. I'm going to show you guys how we can do that in an easier way. Okay? So here's the problem once again. 2.45 times 305. We are going to actually change the problem to make it easier. Wouldn't that be nice? Don't you think it'd be easier if there was no decimal point there? So how, if I have 2.45 and I want to get rid of the decimal point, can I just erase it? No, but I can move it over here by doing something. What can I do? What can I do? Multiply by 100. So we can write, and if you're going to do this, you have to write this down in your notebook, that 2.45 times 100 equals 245. And the reason why it's very important that you write this down is because writing it down will help you remember that you did that. Because if you change the problem, at the very end, what do you have to do? You have to undo it. Okay? Very important to undo any changes you make. Okay, now that we've made that change, what's our new problem? 245 times 305. Now it's just a normal whole number multiplication problem. Let's do it. 5 times 5 is?
25.
Turjo, sit down and stop talking. 5 times 4 is? Plus 2 is? Okay. 5 times 2 is?
10.
Plus 2 is?
12.
Okay. Now, how many placeholder zeros do I need to write now?
2.
Because our next number is 3 what?
300.
300, so we have to write 2 placeholder zeros. Now I can do 3 times 5, which is?
15.
Okay. And then I can do 3 times 4,
12.
plus 1.
13.
Okay. 3 times 2,
6.
plus 1.
7.
Okay. So if I add all these up, in the ones I have 5, I have 2 tens, 7 hundreds, 4 thousands, and 7 10,000s. So my answer is 74,725. Except, you guys, what did we do up here? Did we change the problem? What did we do to change the problem? We multiplied by 100. So what do we need to do to undo that? How can you undo multiplying by 100? Gia?
You have to divide it by 1.
We have to divide by 100 to undo it. Okay? So how does the decimal point move when you divide by 100? Right now the decimal point's here. It's going to move 2 spots to the left. So our answer is 747.25. Look back at your estimation. Is it close to 600? Very good. Look back at your area model. Did we get the same answer both ways?
Yes.
how does that make you feel about your answer? Good. What would our new factors be? 1.3 is pretty close to what number? 1. And then whenever we have 1 as one of our factors, do we need to round the next one? Can we keep 26, 26? Or should I round it to 30? Which one's easier? Are they both the same exact easiness?
26 is more accurate.
Yeah, and 26 would be more accurate. So let's just keep it as 26. So we know that our answer should be pretty close to what number?
26.
Okay, let's store that information away in our heads, okay? Now, if we were to rename the units, renaming the units helps us with what?
Multiply.
Okay, so if we were to rename the units, and I want you to write this down so you know which one is what kind of strategy, okay? Do we need to rename 26? Why not?
Because it isn't.
Go, Supan, go. You understand? How come we don't need to rename 26? It's already a whole number. You got it. So, Ara, if we're going to rename 1.3, we can rename it as what? Good. And therefore, if we were, that helps us with an area model, right? Because then we could do 10 tenths, right? And 3 tenths. That little t means tenths. Does that make sense? Right? And then over here we could do 20 and what? 6, right? And then we could do our area model. Does that make sense?
Yep. Yeah.
Okay, label it. We're not actually going to do it right now, but label it and draw what you would do if you were making an area model. Does that make sense? Okay. But we are going to practice changing the number and then undoing it. Okay? So this is what we would do if we were to, or this is how we estimate. This is how we rename units. Now let's use the standard algorithm. Let's change the problem to make it easier. We can think in our head 1.3 times what will help us move the decimal so all we have is a whole number. Andrew?
1.
1.3 times 1? That still equals 1.3.
Yeah.
Huh?
26.
I want to change the problem to make it easier. So if I do 1.3 times 26, is that changing the problem at all? No, that problem looks exactly the same. I want to move the decimal point. Andrew, what do I need to multiply to move the decimal point? By what?
10.
Good. Because 1.3 times 10 will equal what? 13. And now I only have whole numbers, right?
Yeah.
Okay, now let's do the standard algorithm. I'm going to write standard alg. I'm going to write standard alg. Okay. Oops. I don't want to draw a line there. Okay. So now that we've changed the problem, let's do our standard algorithm. What's my new problem, Helmi? 13 times 26. Very good. Okay. 6 times 3 is?
18.
6 times 1 is? Plus 1. Okay. I'm going to write a 0 because now I'm working with 20s. 2 times 3 is? 2 times 1 is? Okay. I have my partial products. I'm going to add them up. 13. Wait, 6 plus 7 is 13. Yep, good. And then 3. So my answer is 338. But now, if I did, it's very crucial. It goes hand in hand. It's like BFFs. You'll never see one without the other, right? It's like you'll never see peanut butter without jelly. They're best friends, right? Or you'll never see ketchup without fries, right? They're best friends. They're always together, okay? So what's the best friend of change? Undo. If you see change without undo, something's wrong, okay? It's like if you see, you'll always have your shadow with you, right? If there's no shadow with you, something's wrong, okay? Unless you're inside or it's dark outside. But do you guys see what I'm saying? Okay? You all raise your right hand. Rishma, raise your right hand. That's your left hand. Raise your right hand. I promise that whenever I change a problem, I always will undo the change. Put your hand down. Okay, if my change, what was my change up here? What did I do to change the problem? Multiply by 10. So what do I need to do to undo? I need to take my product, 338, and divide it by what?
10.
When I divide something by 10, what happens to the decimal point?
Lose one space to the left.
So what is the answer?
33.
Very good. Okay. By the way, if I got my answer and I said that it was 338, is that close to my estimate?
No.
But if I put the decimal point here, is that better?